calling a whistle-stop tour here of a few, I think about 15 schemes that we've worked on this year, starting off with Castle Footbridge, which was last weekend. So we had a lot of bridges last weekend. This was a scheme we were working for Sam Evans, who were working for Amco. There was others involved. There's MHB and PSD involved, and Alltask. It's quite an interesting one to coordinate all the works between ourselves, but it was done over tight time constraints, and it worked very well. And the bridge came down successfully. The scaffold bridges in place supporting the services, which had to remain, which in itself is quite an interesting structure. Not designed by us, but quite an interesting structure. The fact that the pipes aren't hanging below the beams, they're offset. So it's quite an interesting structure, an interesting project all around, that one. We also had last weekend, we had St John's Footbridge came down. This was struck by some RRV, and the weekend before last, we turned up on site on Monday. By Tuesday evening, they had a full demolition scheme in place that we produced, and the works were successfully completed on Saturday night. Quite a simple one, but nonetheless challenging timescales, and it all went safely, which is the main thing. And then similarly last weekend, we had the M3 Bagshot Bridge come down, which was for CDC or Clark Demo. And it's very, very pleasing to talk to your client on a Monday and find out that it went exactly as the predictions and the drawings that we put together. And you can see here the demolition phase. They've just taken out this span because of the nature of it. It was a very long, slender span. Instead of trying to take a lot of weight out of it, we hinged it and failed it, dropped it onto rubble, and that went very, very well, which is a testament to the guys on site, really. A lot of assets to protect on that scheme, from sheet pile walls to the central barriers, telecom services, all sorts. But as I said, it all went very well, and some good pictures floating around on LinkedIn from the Troops plant or CDC demo. A nice one for us, very close to home. This is in Chelmsford, and our office is just outside Chelmsford. This was an old Bailey bridge that was removed. The reason it was lifted out is because the council, in their infinite wisdom, want to keep it, and it's now been dismantled for storage. Folding money says it never comes out of that storage, but that's what they wanted to do anyway. Brighton and Hove for Econ. This was an old bus. Well, this is the first phase of the old bus depot down there. Some quite large span trusses to bring down. Originally looking at cranes, but because of the interface with the railway and space on the site, we pushed down the route of pulling over the structure. So we stripped out the trusses and then folded them over. I can't show you the video because there's too many people squealing in the background, and I'm not going to show that. This one, if you tuned in last month to our webinar on post-tension structures, this is a post-tension bridge, and the name of it has just gone out of my head completely.
Fence line, if that helps.
Say it again.
Fence line.
Fence Lane, did you say?
Yeah.
Yeah, Fence Lane, which came down successfully probably a few months back now, but an interesting one nonetheless. It was for Sam. We were working for Sam Evans. We were working for Balfour Beatty. That went very well. This is Kemsley Paper Mill, where we were working there with Econ. This is just a stack, but there was a lot more work that went on in there. Awful lot of material removed by the Econ team in quite a short period of time. Some good pictures of the stack coming down. This was a scheme up in Yorkshire where we did the demolition sequencing, where you can see, hopefully you can see where there used to be a bridge across that span, a footbridge on the side of the arch, and you can see the new bridge being lifted in. We did all the temporary works for the demo and the new build, and there were some quite challenging temporary works involved with the construction of the second span across the river there. But it all went very well, which is the main thing. Another post-tension structure that came out a few weekends back, which you can see being lifted out on the left, and you can see the new bridges going in on the right. And we did the demolition and the temporary works to facilitate that work, which was a good scheme. This one, Dave.
Yeah, so this was a ballasted tower crane grillage that we were asked to design to situate on a structure in Manchester. So very tight timescales again to get it all designed, fabricated, and installed, and yeah, it all went really well to plan. So a nice little job.
Hopefully they put the Kentledge on before.
Yeah, yes, the photo on the right is prior to the Kentledge going on. So,
yep.
The next one is, I think I've done a webinar on this year. So the dismantling of the container crane at Greenock. So it was quite a challenge to come up with all the weights if there were no archive drawings. So it's another scheme, came down on schedule pretty much given the weather constraints, but yeah, a nice project. And another tower crane grillage over in London for a fairly sized crane. And yeah, we did all the design for Construct It, who got it fabricated and installed. So you can see the shard in the background there, which shows you just about where it is.
Roughly. Yeah. I was a bit worried about putting this presentation together because I've changed my phone this year and I wasn't sure if I'd be able to get my WhatsApp messages, but strangely I managed it. It's amazing, isn't it? Our politicians can't manage it, but I managed it. It's incredible, really.
Yeah.
Anyway, enough of taking the piss out of Boris Johnson. This is a bit more of a detailed case study. This is one of two schemes we've delivered with one of a few schemes we've delivered with Walters this year. This is Pontypridd, and this is the second scheme we've delivered in Pontypridd. They seem to be spending quite a lot of money, the local council, in making the high street a more attractive place. And to be fair to them, they are succeeding. They have now got rid of the two most disgusting buildings that used to be on the high street. The first one you can see in the bottom left corner there. You can see where the picture was actually caught during the demolition of the former bingo, what used to be a cinema, then a bingo hall, on the bottom left there, which was truly an appalling looking structure. And now we're taking out the old M&S and Dorothy Perkins, which sits, actually, you don't realise when you walk through the high street in Pontypridd, but you're sitting above the river. And it's situated just where two rivers meet, River Taff and the river, I can't remember the other one that meets. Anyway, if you're familiar with Pontypridd, you'll probably know that it does flood fairly regularly. And when it does flood, it really does flood. And there's some significant water level rises in the area, which was part of the challenges with this scheme. So you can see how lovely this building looked. And again, if you look at the rest of the high street, it's actually quite nice. Pontypridd, it's worth a visit if you're there. But that was a truly hideous looking pair of structures. So we're taking out from here all the way up to that building there. You can just see the gable end wall sticking out. And that's a view from the rear, that lovely, elegant building that really blends in when you look at the buildings around it. There you go. You can't help town planning back in the 60s, can you? They didn't seem to care what things looked like, or had completely different ideas to we did. But you can see there that the structure is actually located above a bridge, or the bridge forms the lower level of it. And you can also see, again, this picture was taken when they were working on the bingo hall. Actually, you can see in the background the scaffold around the bingo hall, and you can see how tall that bingo hall was. It was really an overbearing presence in the town. Underneath there, and that's what the bridge looked like. So you had all sorts of different arrangements of structures, from the large span here to the short span spanning onto masonry piers. It was a right old mixture of bits and pieces based upon when things had been built and all sorts. So it was a mess of a structure. There, that kind of shows what we had to take down. And the demo sequence, we basically worked our way in from the rear, so the riverside, taking out all the small buildings, and then worked our way in. And there were some very, very significant steel beams in that structure, very lumpy. It was quite a strange structure in terms of stability, because a lot of the steel beams sat onto very, very slender steel piers, and there wasn't a great deal keeping it all together. So keeping it stable in the temporary state had its challenges for the team on site. You can see that a lot of the work towards the rear was done with a high reach until the decision was made to keep the rear wall to become part of the flood defences of the town, and we had to change to manual work to make sure we didn't crack or dislodge it. But we got a good chunk of it down with the high reach to start with. It gives you an idea of the scale of the building that we were taking down here. As I said, this is some of the smaller beams that were present in the building, but you can see there the spindly columns on which they sat, and you would think it was tied to the concrete wall next door for stability, but it wasn't. The whole thing was very lively and definitely relied on the diaphragm action of the timber floors for stability. So it took some careful work on the part of the teams on site to bring it down safely. When we finished the scheme, it was left like that. So you've got party wall support to one side. You can see there the propping that went in to make flood walls. That gap there doesn't exist, obviously. It just, the CAD drawing isn't quite right. And on the front facade there, we've got bracing to make flood walls, and you've also got a hoarding that sits there, and that hoarding has been designed for impact load from vehicles, which was a requirement of the tender. So quite a hefty hoarding with significant bracing. And there you can see the scheme. The whole building's gone now. It's made a big difference to the site, or to the town itself. You can see the party wall support on this side, and I don't think the hoarding was in at that stage. But it's been an interesting project. Quite a few site visits. I think James and I have both been down there a couple of times to see what's going on and how the project has been developing. And you can see the front. Unfortunately, they still kept part of the horrible facade, but still a big improvement. And I think the final solution, or the final what the council are trying to achieve, is you can see in the background up there the station. So there'll be an entrance from the station that will come all the way down through the former bingo hall site, and then across where the M&S sat, and then that takes you out to there's actually a Lido in Pontypridd and some quite nice gardens out back. So hopefully the council succeed in it, and it does what they hope, because I don't know what I was going to say there. Anyway, kind of went off on a tangent there. Anyway, so the next one is for Waters again. This is Newport Center, and you can actually see that that Google have again caught the demolition just after it started, which was quite interesting, and even in 3D. It looks like that the trusses are floating, but they definitely weren't floating. It's interesting to see that they've caught this midway through the demolition, and it's actually shows exactly what we did. We started at the back of the structure, which was the old sports hall, and that had some very, very large steel trusses in it. Thankfully, when we were on site, once they won the tender, it was after tender, we found up in the old air handling unit rooms, we found all of the structural drawings, and then a month later, the council then found another load of structural drawings. So we were able to confirm the makeup of the structure and the weight of the trusses based on the SI that we did and the drawings that we had. And interestingly, the drawings that we had were clearly changed because there was a truss missing from the design that we had to what was actually built in the structure. But with the SI we had, we were able to go through and verify the weights and the makeup as it was. Luckily, if we just worked off the drawings, we would have told them there was one truss more than there was. As I said, we worked our way from the back of the structure through, taking down what we could with a high reach and then lifting down the trusses. Did weight takeoff as the trusses. And as I said, you can see there the arrangement of the steelwork within the building, fairly significant. Plenty of scrap money. So Waters were very happy. Probably the most technically challenging part of the demolition was taking down the old pool hall at the back, as you can see in red there. So weight takeoff on a demo sequence, fully analysed to demonstrate how we could take it down. So I think Dave did that, didn't you? Did the bulk of the engineering on that one.
Yeah.
And then a nice demo sequence which showed exactly how to do it, which is to cut out the spider in the middle. Well, strip the roof first, cut out the spider in the middle, and then work your way around, taking the weight out of the structure. You can see here again, Google have called it midway through the demo. That's how the structure looked once the roof had been stripped, or most of it had been stripped. I don't think the photos do it justice. You don't realise quite how big this structure is till you're standing inside it. Then pair of cranes, one to lift and one with a man riding basket, and that was used to then lift out the spider in the middle. There's a video on Twitter that Walter's put up if you want to go and see it. I couldn't figure out a way to get it to the presentation, so the right hand side is just a still from it. Suffice to say that it all worked, and the structure behaved as we expected, which was hardly surprising as it turns out, because that's the way they built it. It was pretty much the reverse of what we did, but we didn't know that until later on. Now this is Dave's going to take us through this one.
Yeah, so I was going to chat about the chocking frames at Leadenhall. So Leadenhall is a new structure in London. You can see Google's captured it when it's just a hole in the ground there. We were working for Construct It, but the principal contractor was Multiplex. So highlights for both me and James, who've done the majority of the work there, have been 2 internal climbing cranes, which we're going to talk about now, and done 3 other grillages for the cranes on the site, along with other sections of work. So the chocking frames, if we just move on, we can see what we're talking about here is a crane that's essentially floating within the core. We provide lateral support at 2 points. You kind of see if Angus flicks the button, and then we need to transfer the vertical weight from that crane as it moves upwards to the core, and that allows it to kind of climb up. And over the course of the construction of the building, we climbed the cranes about 10 times. So our challenge was to provide that both lateral and vertical support that could work within the tolerances of the core, and kind of allow these cranes to operate with some fairly sizable loads. They're not small cranes. So move on, what we designed, and we started this back in mid 2021, so it's been quite a long design and kind of build and install, and now they're all fully finished, was 4 unique frames. We were limited by the jacking capacity of the actual cranes themselves for the weight. We also had to kind of deal with the vertical support beams, so how to transfer those loads or the vertical loads to the core. We had to make them retractable so that we could move that. And then we also modified, so TC2 had some inbuilt climbing feet that almost were the right size for the core, so we had to modify them. And we designed some trailing decks to provide safe access for the crane driver, inspections, and to allow them to be installed. So if Angus clicks a few, you can see a few of the 3D models of these. It was quite challenging to design something that could be installed and could provide the kind of tolerances that we needed. We also installed some kind of some jacking feet you can see there that provided the adjustment, and then the vertical support beams that are the pink ones shown there, which kind of transferred the load up. I found taking pictures of this very challenging, given we're in a core, and the pictures, again, don't really do it justice, but it was very kind of hard work to get this installed and to kind of design it so that it was constructible and could be all moved around as easily as possible. But it was tough the first few climbs, but after that they got into a rhythm and it worked really well. And this was when I was last down in London a couple of weeks ago, and with the cranes pretty much topped out there, you can see the rest of the structure coming up behind. So it is definitely been a challenging project, and I think we're going to do a full webinar on what the engineering behind it next year. But it's been definitely one of my highlights of the last couple of years, designing and managing the interfaces on this one.
I think it's a highlight of one of the most technical things we've done, actually, Dave, isn't it? Overall, as a business, it's been a really interesting scheme to develop, and said you've done the bulk of the work on it, that's for sure.
And the cranes are they're out on their grillages on top of the structure, which been their own little challenge, but it's been a very nice little project. I'm now going to run through Josh's project, his favourite project of the year, which is Fiddler's Ferry and the blowdown and other associated work we did. So we're working for PP O'Connor, who are the main contractor on site. SES were doing the explosive side for the blowdowns, and then the overall client is Peel. So the works we did, so it wasn't just the cooling towers. We were working on the northern cooling towers and the whole coal yard. There was quite a few conveyors and things that had to be brought down as well. So Josh has taken yet another selfie there, which shows the kind of the extent of the site behind him. We kind of demolition of some large conveyors, bridging assessments for plant crossings, whole bunker which demolished above ground level and then backfilled above or backfilled below ground level. And then the cooling tower, which I'm going to speak about in a bit more detail. So general principles behind cooling tower demolition was to kind of provide pre-weaken the cooling towers, explosives, and then perform two essentially cuts. You would move the columns around one side and then provide a cut further up as well to ensure it was brought down. There was quite a bit of elements that required protection. You can see there that we were protecting some national grid transformers. There were some services nearby. We carried out all the vibration assessments and the protection measures associated with that, along with the pre-weakening. The next slide shows some of the assessments that we carried out for the pre-weakening. So our role is to essentially assess when we're installing all these explosives, when we're drilling all the holes in the skin of the tower, is that still safe? Is the tower stable under that condition? So there's some fairly complicated wind load assessments and looking at the pre-weakening works that we did there. The other important element is the test blasting. So you can see here the kind of we test blasted one of the columns and some of the skin of the cooling tower to ensure the explosives that were selected by SEF were suitable and would provide enough bang, let's say, to pre-weaken the structure fully. And the next image just shows the inside of the tower after that test blast. So you can see it completely removed one column and the blast in the shell worked. We actually reused a lot of the old conveyor belts to form the protection there when we were doing those test blasts. And PP O'Connor did a lovely video, although the day was very foggy. So hopefully this plays all right. That kind of shows the site afterwards. So the only thing that could have been better was the weather really there. So it was, yeah, another successful project for the year, and it's only just really finished. So it's been good. I think next one is Richard's project.
I think it is, and it's oh, we've skipped a good few slides there. Yeah, it's kind of a come down after talking about the big blowdown of the power plants to talk about just a mechanical demolition of a structure, but there's a slot I was given, so oh well. If you move on, but Angus, so it's Laurie House. It was in the middle of Derby and quite crowded little area. You've got buildings on all sides. Fortunately, the building to the left you can see there came down before Laurie House, which is in the green. And then in the cross section, the nightclub that's in the blue over there came out before it as well. But tucked away at the back there, you can see a wee masonry clad structure that had to stay in and was very close to the building, which was one of the biggest issues. So Laurie House itself, it was 8 stories and we had to bring it down mechanically due to the proximity of that building. You can see there's 2 cores in the structure. So you've got the south core and the north core, which was right next to that building. There was very little clearance between them. So the plan was to take down that section of the building first. And so if you do that section of the building first, you take that down, and then if you move along, Angus, you're left with quite an unstable looking setup with no core on one side and just the south core left, which isn't a great idea for stability, but it was that just the proximity of that building tucked away at the back there. So if you move along again, Angus. So what we did is we checked the structure in a FEA analysis You can see there's 13 bays or 13 column lines there. And the first 3 we were going to take away before anything else. So when you take that away and you move along on the slides, you can see we've checked the existing condition of the structure, and you can see the distribution of the loads there. It's basically exactly what you expect a tower to be under when it's under wind load from one side as well. You can see it's cantilevering on one side, and then when you take away the 3 frames, we compared it to what we were proposing. Yeah, don't move along yet, Angus. Move back. There we go. And you can see we checked it in the state where the N3 bays were taken off. But in that state, the forces in the tower were far higher than was acceptable, really. And so we devised some bracing that can go in. And there's the bracing we did. You can see it in base 6 there. Base 6? Yeah, base 6. Just to lower the loads. And if you compare the loads on that to the loads that were in the existing structure, it was fine. I know the colors don't look the right, but it was just a change in the program. The loads were about the same in the existing structure as they were with this braced arrangement. So if you move along one more time, Angus, when you're doing the demolition from one side, obviously you get to that braced bay first. So we had to also check out when those braces were demolished along with the structure. So as long as that was stable and the braced arrangement was stable, you could take out the north core first and then work your way to the south, and the building would remain stable the entire time. And really, it was just a quick run of how we do the FEA analysis. And if you move one more time, you can see. Okay, and that was the design of the braces that I hope everyone can see. And because we already had the full FEA analysis, it was very easy to design the braces. We knew all the loads in it. So you had about 11, 12 tons in one of those braces. So we had to come up with some ingenious ways of doing that into the existing columns, but that all worked out quite easily. And if you want to move along, and that is one of the great Google images that's partway through it. You can see they took down the core at the top of the building, and then they moved south towards the rest. And that is them just after they took out the braced bay, which is a very convenient time for them to get a picture on Google. And I think I'm passing over to James now. Yes, I am. I'm passing over to James. There you go.
Yes. I'm going to talk about the works on Merrion Street with Construct It, which consisted of 2 tower crane tie arrangements. Angus, would you mind moving to the next slide, please? So the construction sequence for the crane is shown, for the project, I suppose, is shown below. In phase 1, we've got the core has progressed up to around 85 meters in height, and the floor construction for the structure that surrounds the core is progressing, but at a much slower rate. Then, in order to allow the tower crane to service the full height of the core, it had to be tied to the structure because it couldn't freestand any higher than it got to. So we had to tie that crane to the core to enable the phase 3, which is the core going to the full height. And then following that, we added an additional tie, which was to a bridging column, and removed the core tie, and then constructed the final couple of floors. Would you mind clicking, Angus? So our involvement in this scheme is the 2 crane tie designs that are highlighted on the image. I want to click again. The first tie positions and loads were the tie positions and the loads were specified by the crane supplier, and the loads were in the region of 300 kilonewtons unfactored. Due to constraints on site, the fixings had to be post-fix, which is not really typical of these sort of connections. Normally you would embed a plate within the actual core walls that's got shear studs on the back and potentially provide additional rebar just to ensure that the concrete, those ties don't break out of the concrete core where you tie into it. But obviously that wasn't possible in this instance, and it made the bracket designs a bit more interesting. Things that we had to consider in the bracket design was the anchor spacing. The closer the anchors are together, the smaller the block breakout of the concrete would be. The rebar within the wall, you can see that we've allowed on the bottom left, bottom right image, we've allowed 4 bolt holes per anchor that was required to assure that we can install this and avoid hitting rebar. And the other key item was stiffness and the relative stiffness between the anchor plate and the wall to ensure that the load distributed as we intended through the anchors. And yeah, here's some images of our analysis of that. But yeah, and here we've got some photos of the installation, which again, this was by Constructit. Access was possible via a mast climber that was placed on top of the floor slabs where they're cast up to, and we'd specified that a template be made up, which is the photo on the left-hand side, just to ensure that the fixings were all installed in the correct positions. And then Constructor used a system of chain hoists to get the actual bracket into place, because these brackets were big old brackets. I think we're talking about 700 kilograms each, so it's not an insubstantial thing. And then the image on the right hand side shows them in the as installed position as they've been moved over with the chains, which is quite an interesting thing. If you want to move to the next one, Angus, we can see some photos of the crane in use with the ties installed, which is always nice to see. Yeah, that's it. So moving on to the bridging column design, following liaison with the client, we were able to use the casting brackets on this design. So the installation sequence for these was to cast in a bracket on level 25, then to install the column and with the upper bracket attached, and then cast in the floor 26. So it was already there and enabled installation a lot easier. It did come with problems in terms of the removal of this column, but that was preferred by our client. That they were happy that, or they preferred to burn it out rather than for us to provide additional details, because of the we looked into to detailing a way to enable this to be removed easily, but they preferred just to burn it out essentially. But the design of this bridging column was influenced heavily by the stiffness requirements to limit the crane sway, and in order to achieve the shear capacity required on the casting plates, we essentially introduced our own moment connection at the top and bottom of the connection, because there was that many bolts required that it formed a moment connection. So if Angus, you want to click onto the next slide, I can show you how we dealt with that. So we produced a simplified model of a portion of a structure. The basis of the model is shown on the top left, and a 3D rendering of it below. So the permanent columns were treated as pin supports in the analysis, and the only column or the only link between the two floors is the bridging columns. On the bottom left, you can see I've blanked out everything other than the main axis moments of the columns. So you can see there is a significant bending moment being transferred in a couple of instances, about 86 kilonewtons, I think, if I can read that, to the slab. And so we had to check the slab for the punching shear for that moment, and then following that, we did a comparison of the bending moments in the slab on each floor in both the current condition, or the design condition with the live load on it, versus that condition with the temporary tie on it. And we provided a local live load exclusion zone, which is what's shown on the right hand side of that image of the screen. Angus, do you want to go to the next one? So this, again, it's back to Leadenhall, which is, it's a bit of a teaser really ahead of our presentation next year. So Dave mentioned there was a couple of grillages on the roof, and I think he somewhat undersold it, because these were not really ordinary grillages, and the one that you can see here cantilevers off the edge of the core, and it's on floor 22. So in our future presentation, I'm going to be discussing in a bit more detail the design of those, the design of the cast-in plates that you can see detailed on there. Look at the tower crane ties above a little bit, and I will be discussing how we installed this and the work that went into providing access and installation for the installation, because we did a full installation sequence, which is quite a thing in itself. And that's the end of my mini presentation.
You can see there the more typical kind of embedded plate there, James, can't you? That you would have typically thought of Marion.
Yeah, and I mean, these are somewhat larger than a normal one because they are picking up a lot more than a normal tower crane load as well. So, but yeah, this is a big version of what you'd normally expect.
There was some interesting conversations we had on this one, wasn't there? On the, as you touched on, the stiffness of the anchors and the plate, wasn't it? Figuring out how far the anchors will move before they pick up the load. It was an interesting one. Quite a simple one, but actually quite a cool thing to design, wasn't it?
It was, and I mean, my involvement on this was on that anchor was the Cat 2 check.
Yeah.
So Chris did the design on this one, and yeah, it was a couple of interesting conversations we had along the way.
Yeah. Yes. Right. So another good year for us all here at Andon. I think we've delivered over 1,500 projects. And there might be a lot of tasks in each project, but there's 1,500 individual projects I think we've worked on this year. Done 11 webinars because we had August off, or did we have July off? I can't remember. One of them, we all decided to have a break for a month. We continue to grow, continue to invest in what we need as a business, as more employees, and we're still continuing to develop or focus on developing our engineers to take on these technical projects. Hopefully you've seen today there are some seriously challenging projects that we've been involved with this year. As I said, we operate out of 4 offices across the UK. So we're never that far away from you if you need our assistance on site. And just feels a bit early because we normally do this a week